class. We've been talking a lot about pressure, and pressure not only has to do with chemistry, but also has to do with weather systems. So we're currently in a low pressure system here at the beach, which means we have lots of wind because high pressure systems around us are pushing air down, and that air has to go somewhere, so it comes to the low pressure. So lots of wind means lots of waves. Lots of waves means lots of surf. So anyways, it is a surfy, wonderful day here, unlike the weather we are obviously having in Kansas City.
Right, so tonight's podcast we're going to talk about units for both pressure and temperature. Okay, so we have a definition from pressure that's from another podcast, and it's related to how often particles hit the walls of their container. All right, and pressure is always measured. So, right, pressure. One we're familiar with is pounds per square inch, and pounds is a force, and square inches is an area. So pressure is always equal to force over area, because it's pounds per square inch. So force over area. And I just put, as an example, 15 psi. And psi is pounds per square inch. Alright, usually your bike tire is like 30-35 pounds per square inch. So the SI unit, or the metric unit, and again, metric is always different than what we use here in the US, but the metric unit for pressure is known as the Pascal, right? And this was named after a gentleman who was a scientist. He was French, but Pascal, it's named after him. And this number is essentially our force, all right? Well, a couple things are happening. So we're going to go into a little bit of physics. Force equals mass times acceleration. All right? So force equals ma is the equation. Force equals mass times acceleration. So if we're talking about air pressure or atmospheric pressure, the air has a certain mass. We don't feel that because we're used to it. Okay? But if you could imagine something that was a meter by a meter. So a meter is about 3 feet. If you drew a 3 foot by 3 foot square on the ground, okay, and just drew that until you hit space, so it's as tall as the atmosphere is, that square, that's really quite small, would weigh about 10,300 kilograms, so about 22,000 pounds, all right? Why it doesn't crush us is our bodies are used to that much pressure, okay? So the mass of air is going to be 10,300 kilograms, okay? And then we're going to multiply that by the acceleration due to gravity, all right? And that's always 9.8 meters per second squared. All right? And the area we've already talked about is 1 meter squared. So it was just a meter by a meter, okay, about 3 feet by 3 feet. So when we do that math, we find that this comes out to approximately 101,300 pascals. All right, and it's usually abbreviated PA. All right. Well, this is the same as, all right, if we use just metric conversions, 101.3 kilopascals. Because remember, a kilo is just 1,000 of something. So a kilogram is 1,000 grams, just like a kilometer is 1,000 meters. Okay, so that is one of our relationships. Another relationship is this is also equal to 1 atmosphere, okay? And an atmosphere is just abbreviated 1 ATM, and we typically will use this in chemistry even though it's not a metric unit, all right? And two others I want you to be familiar with is obviously going to PSI, or pounds per square inch, and that is 14.7 PSI. And that's also equal to, and we're just going to do this one, 760 millimeters of mercury. Okay, so mm is millimeter, and Hg is our symbol for mercury. So these relationships you need to memorize, all right? And we can do fence and rail problems just like we can do any other basic problems because we're just converting. So for example, if I gave you 53 psi equals how many, let's do kilopascals, all right? So we're going to start with what we know, So what do we know? We know 53 psi. Alright, we're going to do our fence post. And we're going to let our units be our guide. So psi is the numerator, so we need to put psi in the denominator. And we want to solve for kilopascals. Alright? So is there a relationship that relates these two things? And there is. For every 101.3 kilopascals, there are 14.7 psi. We'll just set our problem up. Notice psi's go away. We're left with kPa, which is what we want. And for this problem, you're simply going to multiply across the top and divide by 14.7. And we can pull the calculator up and do that. So we're going to take 53 times 101.3 and divide that by 14.7. And we find that's about 365 kilopascals. Alright, the other thing we need to learn is temperature. Okay? And temperature, typically in science, is measured in degrees Celsius. Alright? But in our gas unit, we're going to be introduced to the Kelvin unit. Okay? So degrees Celsius, but you need to know what kelvins are. Alright? So in order to go from Celsius to Kelvin, it's a fairly easy conversion. Kelvin is always going to equal degrees Celsius plus 273. Okay? So if it's 25 degrees out, 25 degrees Celsius, which is about room temperature, if we add that to 278, we would get 298 Kelvin. Okay? Kelvin can never have negative temperatures. Okay? So Kelvin is always positive. Or you might put never negative. And that's why we use the Kelvin scale. Always positive values. Okay? And that is the conversion. Kelvin's equals Celsius plus 273. Or, if you're given Kelvin and need Celsius, this is fairly easy. Degrees Celsius equal Kelvin minus 273. Okay? And that's just a little algebraic manipulation. Okay? The very last thing you need for your notes is what's known as STP. And this stands for standard temperature and pressure. Okay? So STP stands for standard temperature and pressure. Standard temperature is 0 Celsius or 273 Kelvin. Alright? And standard pressure is any of these values we have listed up top. Okay? So this whole row is standard pressure. Alright? Any of these 5 values, 760 millimeters mercury, or 14.7 psi, or 101,300 pascals, 101.3 kilopascals, or 1 atmosphere, is all known as standard pressure.